This is a Micronta 22-025 vacuum tube voltmeter from days gone by, and it's a little rough shape. It's got some rust in the case, and looks like there's some damage here. Something infiltrated underneath the plastic here. I can't read. Well, let's see, this is AC balance. It's got a little pot here. This is where you connect your probe. Not sure what these leads are, but I do have a schematic for it I found on the internet, so should be able to fix this. Here's a page out of the 1968 Radio Shack catalog, which has this VTVM, the 22-025, $39.95. So there it is, back in 1968. I haven't had this thing powered up, but let's see what we get when we turn it on. Ooh. Well, let's see what happens here. Can we zero it out? No, we can't zero it out. And I'm going to turn it off because that's pegging the needle there. That's not good. So something's out of balance, obviously. So I guess we'll open it up and do a visual inspection. Here's the unit, and here's the insides. Oh, it looks pretty clean. There's some damage here on the battery terminal, so most of these old VTVMs, they left batteries in them, so they'll have damage like this. And probably just a carbon zinc battery, so it's not going to be able to clean it up with vinegar here. I think what I'll do first, I'll test the tubes, see if they're any good. These are nice switches here. This is like a phenolic, but the other switches here, it's some type of plastic. Yeah, this is well constructed. So I think the next step, I will I'll test the tubes and see if that's the problem. If not, we probably have to do some work here. Here's an electrolytic that's probably going to need replacing here. Old diode package. Let's see. Yeah, these were nice meters. Here's the schematic of the VTVM here. And this is a classic circuit. It uses a 12AU7 here, and you can take a look at here if you want to look at the schematic. This is available on the internet. I got it. I can't remember where I got it, but it is available. But anyway, I pulled a 12AU7 out, and something I noticed was the pins are pretty corroded. There's some green on them. So I don't know if that is part of the problem or not. Hard to tell. But I'm going to clean the pins off. I'm going to test the tube anyway since I got the tube tester out. But I'll test this tube first, and then we'll go in and take a few measurements. Make sure the power supply is okay, etc. The trusty old Hickok 752. I don't use this much anymore. I'm not a vacuum tube guy. A few things, mainly transmitting tubes, but see if I got this thing set up here. Alright. Let the tube warm up for a minute. And according to the sheet, want to press S5, and it's a dual triode, so we'll have to push S8 to test the second plate. So the tube is good. Well, I'm going to put it back in and see if it was just corroded contacts. Couldn't be that easy. So that's the next step. Here's the socket for the 12AU7, and as you can see here, it's green. A lot of corrosion in here, so I don't know where that's from. I pull the other tube. I do it with one hand here. This one is used for the AC range, and this one looks alright. The pins are okay, so it's just the important tube. So I'm going to clean the socket pins here, and then we'll try it again, see what happens. This is the 12AU7 that had the corroded socket on it, and when this meter is in the vertical position, you can see the battery compartments right above this tube, and looking at that corrosion in the green color, obviously it appears that that battery leakage had come down, migrated into this socket, and caused the contamination, corrosion of the socket, which was a result of the machine not working here. So anyway, it's a good idea not to leave batteries in these things. Any of these old VTVMs, I never leave batteries in them because I don't use them for resistance. I'll use a digital meter for that. The only other one, I did a video on an old ICO VTVM, which I like because it's got a huge meter face on it. And if you want to look at that one, I replaced the battery supply, the 1.5 battery supply. I tapped off of the filament supply and added a small DC supply to run the ohmmeter. But I'm not going to use any of these, so rather than having to open it up and put a battery in it every time you want to use it, or risk leaving a battery in it, because you know it's easy to forget you got batteries in these things. Unless you put a tag on the back and write the battery date, but still you're risking this, and those batteries when they leak do a lot of damage. And once the battery's exhausted, they pretty much most of them leak. I was surprised. I had an old meter one time, and it had an old Railvac battery, and it had the old style I remember as a kid back in the 60s, and that battery had to be really super old, and of course it was completely dead, but it hadn't leaked at all. But my experience with Railvac batteries, they tended to leak quite a bit actually, but the old carbon zinc batteries. Anyway, keep the batteries out of your meters. Okay, I cleaned the pins on that tube and I cleaned the socket. Let's see if we get any difference. Anything different here. Well, what are we doing? Looks like that did it. It's warming up here. Well, if only everything was this easy to fix. Yeah, it's still drifting. We'll give it a chance. I'm going to put it on plus DC. I'll let it warm up for a little bit. I think I have a Pro for that'll work in this thing. Let me go get that and we'll see what we get. The calibration pots are located on the board here. Unfortunately, they didn't mark what's what, but by trial and error I determined the top pot is the plus DC adjustment and the middle pot is the minus DC adjustment, and those are the only two that I'm really concerned about. So I connected them up to a voltage source, and I'm going to compare the meter here, the VTVM, to a digital voltmeter, and then I'll adjust these pots for both the positive and the negative on the function switch here. So that's next. Okay, I've hooked the VTVM and this digital meter on the left to a bench supply, adjusted it to 45 volts, and I've calibrated the VTVM on the 50 volt range. You can see it's at 45 volts because you want to make sure the meter's zeroed. So 45 volts is right there. And now I will connect the supply backwards. And we'll see if we get minus 45, which we do. So with a function switch on DC minus, I'm getting 45 also. And the other ranges were really close, off a little teeny bit, but you know, this thing isn't going to be compared to a modern meter anyway. But and when you take measurements on these things, you always want to take a measurement with the needle in the upper third of the scale for the best accuracy. So here's the 150 volt scale, which should be here. So yeah, you can see it's reading a little bit high here for the negative. Let's see what we got with positive. It should be the same. Yeah, it's reading slightly high, but that's close enough for what I'm going to use with this thing, so I'm going to leave it at that. Well, this was a pretty easy repair. I was surprised that it was just a corroded tube socket contact to the vacuum tube. So if you get one of these, they're fairly easy to work on. The schematic's available. I didn't see another one of these on any YouTube sites, this particular meter. There may be some I missed, but that's why I did this video. And you'll find these, if you want to get one of these, I'd stay away from eBay. Go to a ham fest. That's the best place to go. These things are all over ham fest. Every ham fest I've gone to the last few years, you'll see quite a few of these old things, and people don't seem to want them. They don't seem to sell for very much. This one I think sold for, I had a box of them. I think they were like $5 a piece. In the end, I got a few different ones. This Micronta one, I got a couple RCA Voltomus and an older ICO. I think he threw in a couple of, actually threw in a Simpson VTVM, which was actually kind of neat. I might do a video on that one. So anyway, hope you enjoyed this video. I hope you get something out of it, and thank you for watching, and I will see you in the next one, hopefully. Bye for now.